Hi, in this video we will see the very important topic in database management system, layers of abstraction, also known as three-schema architecture or view of data. We will also see examples of layers of abstraction so that you have a clear idea about this topic. The three layers of data abstraction in a database management system are shown in this figure. The layers are physical level, logical level, and the view level. So what is actually data abstraction? Data abstraction means the users must be hidden with the complexities of the database system. That is, a user need not worry about how the data is stored at the physical level, how the design is done between the different logical structures at the conceptual level, and what other users are viewing. A user need not be aware of at the top level. So these are basically the three layers of abstraction which the database uses to hide the complexities of the database system with the users. Now, system hides certain details of how the data are stored and maintained. For example, you are working at the view level, that is, you are accessing a web application of a bank. What you provide there is a login details, right? Username and password you will provide. You need not worry. You are working at the top level here, view level. That means you need not worry about how the data is stored at the logical structures, what are the tables created in the database, and what are the files available, where the data is stored, how it is accessed. These you need not worry as a user. Simply you can click any button or any menu so that you can easily access the database content which is required for you. So databases are unique in their ability to present multiple users with their own distinct or different views of the data. That means there are many users who are accessing the database at the same time, right? A real-time online application, thousands of users or sometimes millions of users will be accessing at the same time. So each user will be accessing his or her own data, right? So database provides different users with different views. For example, a manager may have a different view, an entry operator may have a different view, right? A sales executive may have a different view of the data. So in that way you can understand. So these are called the views. These are called the views. For example, in an organization, a manager may access sales reports or the analyze information about the profit and sales. Whereas a simple salesman, he may view only about his sales, what he has done in a month or in a week or in a day, etc. So different views are provided by the database system. So all this is possible through the layers of abstraction which is provided by the database system. So basically these layers of abstraction are divided into three layers. The physical layer at the bottom most part, and the middle level we are having the conceptual level, and the top layer, that is the external layer or the view layer. The most common the complex difficulties are available at the physical level. Now we will see the first layer, that is physical layer or physical. This is the lowest level here. Lowest layer of abstraction, that means many complexities are there here. How the data is actually stored is hidden from the user working at this level. For example, who work at the physical level? The DBS work. What is the job of the DBA? Right? They create, for example, database, and database is stored in different files in the hard disk. Right? Who manages the hard disk? DBMS manage along with the operating system. Right? So physical layer contains complex data files that hold all the data for the database. For example, a university database or any defense organization database. The complex data files here, many data files are there that may be in one disk or that may be in different disks working in parallel to provide maximum performance. All these things that the DBA need not aware, right? DBMS hides these difficulties even for the DBA. Only DBA creates the database. He mentions the file names about some size and increment features, etc. He need not worry about how the files are opened, how the data is closed, right? How the data files are stored in different disks working in parallel to provide performance. All these things are hidden from the DBA. So that is what an abstract view of the database system is given to the DBA who is working at the physical level. Right? These facilities are provided in most of the modern DBMS that are available today. How the files are closed, how they are opened, how the operating system read from the database, all these things are hidden from the user. Who is the user working at the physical level? The DBA, the database administrator is working at this level, and even he also need not aware of the difficulties that may happen at this level. Now the examples, we can say examples of the physical level of abstraction. Relations are tables that are stored in one or more files. For example, if we have created a table, it may be a part of one file, physical file at the disk level, or it may be a part of more than one file at the disk level. Storing a student record as a block of consecutive storage locations. That means when we store a student record or a patient record or a sales record, that will be stored at the smallest level, that is a block, right? So the disk contains the continuous blocks where data is stored of different tables that may spread in different physical files. Now the second layer is logical layer. Here difficulties are somewhat less compared to the physical level, but still there are difficulties. So what is conceptual level? It is a logical level, logical structure. For example, table. We know that DBMS store data in tables, and there are relationships in the tables. So at the logical level of abstraction, discuss what data are stored. For example, a student data, student modules data, faculties data, how the different tables are related. So that is what we say, what data are stored and what relationship exists among those data. When you see the example, you will clearly understand about this logical, the middle level, that is conceptual level, or the logical level. So the logical level thus describes the entire database in small number of relatively simple structures. We create here index, we create here what we say tables, we define the relationship, we choose the data types, we implement the constraints like primary key, foreign key, all these things. We implement all these things at the logical level. So the database user working at the logical level does not need to be aware of the complexities at the physical level. What is abstraction here? What is abstraction for the user who is working at the conceptual level? So how the database is created at the physical level, and how the data is stored in different files, how data is stored in different files, how the files are opened, closed, read, deleted, modified, and all those things. The user working at the logical level, he need not worry about all these things. These are completely hidden. The complexities are hidden. So the database provides an abstract view of the data for the user working at the logical level. So DBS decide, mostly in the organization we are having the database administrators, they decide what information to be kept in the database using the logical level abstraction, that is using the logical structures of the database system, that is we can say tables, index, and all those things. This level defines the logical structure, we can say. So physical structures, files at the lowest level, logical structure. Now we will see some more examples we can see that are related with the logical level of abstraction. Tables are logical structure, very simple, we can say. Many logical structures are the tables. We know that we create the tables and data is stored in the tables. From a user point of view, of course, it is stored in files, data files at the physical level. But for a user, for a DBA who is working at the logical level, he knows that the data is stored in tables. So a student table having student ID, name, etc., that is defined here. A module, that is a subject, we can say module ID. A data type, we say module name. Right? For example, DBMS is a module. It is having some module ID DB101. Right, something like enrolled. So how many? Who are the students? They are enrolled in this modules. Student ID will be required. Module ID, and the grade he has scored in this module. So these are some logical structure that is in the form of tables that are created at the logical level of abstraction. Now we will move to the third layer, external layer, or the view level of abstraction. Here different users are working and each user will have a different view. This is the highest level of abstraction, describes only part of the database. Part of the database means, suppose you are a student, you log in into a university database system, right? What you will access? You will access only your information, right? Your modules, your result, your attendance details, right? You need not worry about what the second user is accessing, what the third user, what HOD, the department head is accessing, what are the faculties they are accessing. You need not worry about all these things. So only a part of the database, a very small part of the database is shown to the user that is relevant to him. This also provides the security, right? If you access the database, this does not mean you access the entire data, right? Most of the data may be hidden from you. So even though logical users here at the logical level, there is the conceptual level, we use simple structures like tables, right? There are still difficulties, right? Because the database contains a large amount of information. Every user will not be allowed to see the complete table data, because a complete table data may have marks of the different other students also, right? The personal details of other students also. For example, their mobile number, their email, maybe we don't want to show to them the student, right? So even though conceptual level is better in terms of complexity compared to physical level, but still there are large variety of information stored in the database. So every user should be shown only part of the database. That's why we are having this level. So many users of the database system need not know the complexity of the database systems at the logical level or at the physical level. Instead, they need to access only part of the database. That's why this third layer has been created. So this level of abstraction, that is view level, is existing because database system needs to simplify how the users interact with the system, right? Suppose if you are accessing a bank database and you need to write a query, you need to know what is the table, what are the database, how everyone knows about this one, right? They are not tech savvy, they don't know about the database systems. So database system hides all these things. Even those person who has no knowledge about the computers or who has no knowledge about the database management systems, how the software works, how tables are created, how database are created, they can also easily access their part of the data, right? The view level of abstraction exists to simplify users interaction. That is what we have discussed. So many views are created here depending upon the user's requirement. The examples of external or view level of abstraction, we have seen that we have created logical levels. These are the tables we have created at the logical level, the middle level, the conceptual level, right? But still, if someone want to see only how many students, the count of students who are enrolled in a particular module, for example, DBMS is being studied by how many students. So for that we need a view. We need a different type of information that is not available here. For that, a view is created by that what we can say DBA, and that access is given to the user. So a view to know how many students are enrolled in a module information, right? For example, a head of the department is there. He's interested only to know how many enrollments are there in particular module. So he will access simply this view. He need not know which table has this data, what is the data type. He need not know the physical structures and all those things, how the data is stored in files. For example, in a sales related database, manager may want to know only what are the sales done in a day, in a week, the performance of the sales executives. So views are created so that easily he can get the information he want, and the other complexities are completely hidden. So database provides an abstract view. For example, another example, we may create a view to know about how many students have a GPA greater than 9. Here we are having the GPA information, but it does not give how many students have the GPA more than 9. Simply we create a view, and that access will be given to someone who needs this information. So all other complexities are hidden. He can simply access this view. So this is a very powerful feature of the database system. It hides all the complexities or difficulties from the users. So if you like this video, don't forget to click on the like button. Do subscribe to this channel if you have not already done, because most of the topics related with the database systems, DBMS and advanced DBMS, I will be covering in the upcoming videos. If you have any doubts, do mention in the comment section. Thanks for watching.